Okay, so this was assignment 1. So basically, there are 2 questions. There are 2 business scenario, and for each one, you are asked to do conceptual data modeling. So basically, you have to create a ER diagram based on the questions shown on this assignment. So that was the main task. So let me just go through this question together, and let me show you how we can do the conceptual data modeling and how we can derive the ER diagram. So let me show like this. Yeah, so can you guys see the text here? Is it clear? Okay, if you cannot see or if you have any question, while I'm showing the solution of assignment 1, just use the Zoom chat box and yeah, ask me any question anytime. Okay, put this here. Okay, so let's go through it together. So basically, if we read this, the Abacus industry is a company with a few hundred employees. A database is required to keep track of all employees, projects on which they work, the departments which employees work, and projects assigned to employees. So basically, in this company, we want to build a database system which is able to manage and store information about employee, project, and department and other relationship between them. So that's the main question. So if we go to the next statement, every employee has a unique employee number assigned by the company. It is also required to store each employee's name, address, and date of birth. So the first of all, we have to create the employee entity. So we have to design that first. So here we can create employee entity first here. So we can make it here. There's an employee. Entity. Like this. And each employee has a unique employee number assigned by the company. So employee number is unique. So we can use that to identify each employee from others. So we can use that as primary key basically. So we can use employee number as primary key with underline like this. And then we also want to store employee name, address, date of birth. So we can add the attributes name, address, and date of birth like this. Okay, and the next one is if the relationship. So if an employee is currently married to another employee of a company, the date of marriage and who is married to whom must be stored. So, and however, no record of marriage is required if an employee's spouse is not also an employee of a company. So only when an employee is married to another employee in the company, we want to keep that marriage information. So basically, the married relationship we have to create here. So the married relationship here is between 2 employees basically. So one employee is married to another employee. So in this case, we already have an employee entity here. So the relationship will be unary relationship. One employee is married to another employee like this. So we can create this relationship. And for the cardinality, you can think of this. So for the cardinality, so for the cardinality, basically, it's one employee married to another person, right? Then it's employees. One employee is married to another person, which is employee's spouse, right? So we can think about these 2 people. So from the employee's perspective, so let's think about here. So from the employee's perspective, how many spouses you can have if you are married? So if you are not married with another employee in the company, then it will be 0, right? So you don't have any other spouse who is an employee. However, if we are married, then it should be only one, right? Maximum you can marry to only one person. So from the employee's perspective, there could be one spouse maximum or zero spouse and minimum. So it's a 0, 1. And for here, from the spouse's perspective, so now employee is married with someone, and if we think about perspective from the spouse, so if I am a spouse of someone, how many employees there who's married to me? So if I am a spouse by definition, then it will be 1 and 1, right? So if I'm already spouse, then that by definition it means I'm already married. Then the minimum number of persons who are married to me is 1, and the maximum it will be 1. So you can put 1 and 1 here. So of course, in this case, if you consider it's a relationship of one employee to another employee, not the spouse, in that case you may put cardinality 1 and 0 2. So that's also okay. So either way is okay in this case because in terms of implementation, so we are going to talk about today how to implement a database system. So when you have a conceptual diagram, you change it into relational model, and relational model, based on that, we are going to implement it on database system. And in terms of implementation, there's no difference between these two designs. So either cardinality you choose is fine in this case. So basically, married relationship here is one-to-one unary relationship. So that's the main focus of this sentence. And the last one, the marriage date. We still need to keep the record of marriage date. So first of all, you are not able to put marriage date attribute inside the married relationship because married relationship is a one-to-one relationship. So as we talked last time, when you have a many-to-many relationship, it is possible to store additional attributes into that relationship. However, if you have a one-to-one or one-to-many relationship, you are not able to store any additional attributes into that relationship because only many-to-many relationship will become a table in when you implement it. So where to store marriage data in this case? You can simply store inside employee entity. It's because when you are married to only one person. So when you are married, that means that you only have one marriage date. So you cannot have 2 or 3 marriage dates when you are currently married. So you have only one marriage date for the person you are currently married. So we'll simply put marriage date attribute inside employee entity in this case. So that is for this paragraph. So let's go to the next one. So the next paragraph now, an employee is either a manager or a worker, right? So there could be two possible classification in this case. So it's either manager or worker. And we are interested in storing information about base salary of a manager and the last bonus that a manager received. So for a manager, there are 2 additional attributes we want to store. And then we want to keep information about wage rates of workers. So for worker, we have another information we want to store, but not for manager. And in addition, for workers, we want to collect record information about the type of degree. So another information we want to store for the worker. So basically, in this case, depending whether an employee or manager or worker, there are different information we want to store additionally. So what we can do here is this. So we can create separate entity for manager or worker in this case because they have different attributes we want to store additionally. And in the later paragraph, there are also different relationship each of a manager or worker has. So we can create additional entity here. So employee can be manager or worker. So we can create 2 additional entity. And then we can create a relationship. So employee is manager or employee is a worker. So the cardinality is this. So if so let's think about employee and manager relationship first. From the manager's perspective, if you are a manager, you must be an employee of this company. So it's a minimum one, maximum one. So, and if there's an employee might be manager or not. So here the cardinality minimum 0, maximum 1, because it can be manager or not. And same thing for the worker. If you are a worker of the company, you must be an employee of the company. So there is 1 and 1. And for cardinality here, from the employee's perspective, if you are an employee of the company, you might be worker. In that case, maximum 1. You might not be a worker. In that case, minimum 0. So you can put cardinality like this. And there are additional attributes we want to store depending whether it's manager or worker. So for manager, there are 2 additional attributes we want to store, which is base salary and last bonus. For worker, there are 2 attributes, wage rate and the type of degree type, something like that. And the last one is a primary key. So last time we talked that every entity in the ER diagram must have a primary key. So currently we don't have a primary key for manager and worker here. But as you see from this relationship, if the person is a manager, the person must be an employee. And if the person is a worker, the person must be an employee. So because of that relationship, because of the one-to-one relationship, we can simply utilize employee number. We can bring that here and use that as primary key for manager entity. And we can do the same thing for the worker entity. We can use employee number here also as primary key. So that is for the, this part. And also another possibility is this. So we didn't, so in our class, we didn't cover subgroup and supergroup hierarchy. We didn't cover that. However, if you are familiar with the relational database systems, and if you took a database course before, it is possible you may have some knowledge about subgroup, supergroup, and those kind of a group hierarchy. So in the traditional relational database system, when you do conceptual data modeling, if you utilize a group hierarchy, then sometimes you may use this easier relationship. So that's also possible. So if you use easier relationship, you may represent this diagram like this. So there's employee, and employee can be manager or worker. So you may draw something like this. So you don't need to know about this, but this kind of thing also exists. So because this is a group relationship. So you can make something like this, and you can also mark like this. Then employee is the supergroup. So employee can be either manager or worker like this. So this, if you make something like this, this is also okay because some people use this kind of formulation. But actually, in terms of implementation, again, there's no difference between simply using one-to-one relationship and group relationship. So, so in this course, that's why I'm showing this as a sample answer for this question. But if you make something like this, it's just okay. So that's what I wanted to say here. And let's go to the next one. So again, if you have any question, you can just ask me on the Zoom chat box. So let me know if you have any question. Okay. Okay, the next one is this. So now we are going to talk about the project. the project assignment. Okay, so now workers are assigned to projects, and the database should keep information about current assignments of workers to project. Each project is identified by a unique project name, and we must store the estimated cost of each project. So now we are talking about project. So let's create the project entity here. So the questions say that each project is identified by a unique project name. So a project name can be the primary key. So we can have a project name here as primary key because it's a unique name for each project. And also we want to store estimated cost of each project. So additional attribute can be estimated cost. Okay, so now we want to make a relationship between worker and project. So project may have many workers assigned to it, and our worker must be assigned, a worker may be assigned to many projects. So there's assigned relationship between worker and project. So again, from the project's perspective, a project may have many workers, so maximum many. And yeah, it doesn't, let me see. Project may have many workers assigned to it, and the worker may be assigned to many projects. So from the worker's perspective, worker may be assigned to many projects too. And it is possible, however, that a worker is not assigned to any project. In that case, minimum is 0 if a worker is not assigned to any project. Okay, so currently there is no, in this question, there is no rule specified for the minimum cardinality from the project perspective. So it depends on your assumption. So you can assume that there should be at least one worker, that's fine. And if you assume there can be 0 worker in the project at the moment, then this is also fine. So either design is fine in this case because there is no minimum cardinality specified in the question. And the next one, in addition, each project is managed by one manager. So now there's a relationship between manager and project. So we can say there's a managing relationship between manager and project. So from the project perspective, each project is managed by one manager. So one and only one manager. So minimum 1, maximum 1. So that a project is managed by one manager. And a manager may manage more than one project at the current time. So maximum many. Again, there's no specific rule for minimum cardinality here. So from manager's perspective, manager may not manage any project at a time, or they may manage at least one project by the rule. So either is again fine. So you can make, in this case, there's no specified rule for minimum cardinality for this. So you can make an appropriate assumption, and based on that, you can infer the minimum cardinality. So in this case, either is fine for the minimum cardinality. So that's again for this part. So let's go to the next one. The last sentence here, last paragraph. So let me finish this and let me answer your question. So the last paragraph is about the department. So the company has 11 different departments, each with a unique name. So first of all, again, we have to create the department entity first. So let's make it here. So let's make the department entity, each with a unique name. So department name can be primary because it's a unique name. The database should keep information about department affiliation of each employee. So employee is affiliated with the department. So employee is affiliated with the department like this. So each employee is affiliated with only one department. So each employee is only one. So we can put minimum one, maximum one cardinality so that each employee belongs to one and only one department. And each department has a phone number. So additional attribute phone number can be stored here in the department entity. And each department, and for the cardinality here from the department perspective, even though the question does not specify directly, I mean, it's quite straightforward, right? So each department should have can have a many employee and maximum. And for minimum, we can put one, or also depending on your assumption, it can be 0 to minimum at the moment. So either is fine in this case. And each department is managed by one manager, and a manager manages only one department. So for that, we have to make a relationship now between a manager and department. So we can create another manager relationship here. And we can say that manager is managing department. And the questions say that each department is managed by one manager. So each department is managed by one and only one manager. So we put one and one cardinality here from the department perspective, and from the manager's perspective, a manager manages one department only. So we can also put manager manages only one department. So again, here, this is okay if you assume that a manager may not manage any department. So the minimum cardinality rule is again not specified. So you can choose either 0 or 1 for minimum cardinality in this case. But basically, yeah, this is the sample solution for the question 1. So let me put it here like this. So this is the full picture, the full solution of the question 1. Okay, so let me go to the next one. Okay, so question 2 is here, so it starts from here. So this college, the Marble College, is organized by departments. So there are multiple departments, and each department is identified by a unique 3-character code. So let's make a department entity first, because it starts from there. So there's a department entity, and each department is identified by a unique 3-character code. So there's department code. So it's unique. So we can use department code as primary key. So there's a name for department. So yeah, something for math and something for physics, something for English, like that. So we can put department name here as an attribute. We also wish to store name of, we stored that. And each course is identified by the combination of this code, which is a department code, and a 3-digit number, which is a course number. So we can create course entity here, and it says that the each course is identified by a combination of a department code and the 3-digit course number. So there should be course number. So it's identified by a combination of these two. So these two attributes should be used as primary key together like this. And because a course used department code as part of primary key, there should be a relationship between these two. So basically, department will offers course. So we can create this, we can infer this relationship from this question based on the first paragraph. And each department will provide multiple course, because course is a combination of department code in addition to course number. So on top of department code, there will be additional course number. So that means each department will provide multiple course. Here for the minimum cardinality, you can put either 0 or 1 because it doesn't say that there should be necessarily at least one course offered from the department, but I just put 1. If you put 0 here for minimum cardinality, that's also fine. And each course should belong to one and only one department because there's a department code which identifies each course. And the number of credits offered by a particular course does not vary. So if there's a course, there is a fixed credit. So we can put credits attribute here. Okay, and then, okay, yeah, I think that's it. So let's go to the next one. So now there's a semester. So each semester is defined. So let's make the semester entity first here, semester. Each semester is identified by a 2-character code for the term. Combined with a 4-digit that designate the year. Okay, so year and term basically. So year and term should be both used as primary key to identify each semester in this case. And that's all. So next one. Okay, so once the grade is posted, they are entered into each student's transcript. The transcript has information about all courses taken by student in all semester. The grade becomes part of the student's permanent record and will appear on the student's transcript, which is generated by the system upon request. An example transcript follows. So now basically what we have to do is this. So based on this grade report here, we have to design the database system, which is able to store and manage all this information shown on this transcript. So first of all, let's start from the top. So first of all, this is a grade report for every student, each student. So we see a lot of student information here. So there's a student information. So we can create student entity here. So as you see in the this figure, there's a student ID, which we can assume unique for every student. So we can use that as primary key. And we want to save other information like a student name, mail address, the local address. Yeah, like this. So we can save that. And then there's a semester, which we already created. And there's course information, department information, which we already created. And there's course information, course description. So we didn't save that yet, so we can store that here. And then credits, we already have it, and like this. So here the point is this. So where to store the grade information? So that's the important one. So grade, we have to think about this. So grade, if you think about how this information is determined, it's basically based on a certain student in a certain semester by taking a certain course. The grade will be determined. So this grade information will be determined based on a combination of a student in a semester taking a course. So we can create the relationship here. So we can create take relationship by connecting a student in a semester taking a course. So for the cardinality, we can assume from here. So for a certain student taking a certain course, how many semesters he can take it. So for a student taking a certain course. So student taking a course, a certain course. So how many times he can take it? A minimum 1. So student can take a certain course minimum once. And maximum how many times he can take it? it depends on the business rule, but based on this figure, we don't know the business rule. So you can make an appropriate assumption. So if you assume that a student may take the same course over and over to improve their grade, then you can assume many. Or if you assume that the student can take a certain course only once, then you can say 1 and 1. So either is fine in this case. And let's just think about here. So now a student in a certain semester, how many courses he can take? So student may take many courses in a certain semester, so maximum many. And for minimum cardinality, again, it doesn't specifically say from the question, so you can either assume 1 or you can assume 0 if you allow a student having a break in a certain semester. And here, the last one here is student in a certain semester, yeah, there's a course offered in a certain semester. How many students can take it? So again, maximum many students can take a certain course in a certain semester, and we can say minimum 1. Or if you allow no one taking the course, also this is fine. So either minimum cardinality is fine in this case too. So basically now we have this take relationship, which is many to many relationship, because there are more than one many cardinality in this ternary relationship. So it will be ternary many to many relationship here. And for the grade information, we can simply store here, because student will have a grade based on student taking a certain course in a certain semester, which is this relationship, and we can put grade information here. And also this information. So the credits earned, it depends on the student taking a certain course in a certain semester again, right? Because a student may take it, and if he pass, he'll get the credit. If he doesn't pass, he'll not get any credit. Same for the grade points. So we can simply save credits earned and grade points all together here. So that's for this part basically. And the next one is a semester total here. So semester total is an aggregated information. So basically what happened in the current semester, you aggregate information and you calculate this information here. So credits taken will be simply sum of credits applied in this semester. Credits earned are some of the credits earned here. And GPA is the average of credits earned multiplied by the GPA information something here. So we can calculate GPA in some way based on this information. And total grade point is also sum of grade points in this semester. So in the database system, if you think about where to keep this information, where to store this information, again, you should not think about how this information is calculated. That is not necessary. That is not related to where this information will be stored. You have to think about what this information depends on. So when you come up with this information, what this information depends on based on this diagram here. So in this case, semester total will be given for a certain student in a certain semester. It's not related with the course, right? Because it's aggregating all the information from multiple courses. So for a certain student in a certain semester, we'll have a semester total. So currently, in this diagram, we don't have that relationship here, so we can create one here. So basically, we can say that students are enrolled, right? So students is enrolled in a certain semester, and student can enroll many semesters, including one, and each semester there can be many students, including one. So we can assume many-to-many relationship in this case. And for this relationship, basically, it represents a certain student in a certain semester. And then we can have a semester total here. So credits, so semester credits taken and semester credits earned and semester GPA and semester total grade points. Basically, all these semester total information can be stored inside this many-to-many relationship between student and semester. So that's for that. So here it's the same information, and the last one we have to represent is cumulative total. So cumulative total is again aggregated information for each student. So each student takes a course across multiple semesters, and we aggregate all this information and we come up with this number. So basically, cumulative total will exist for each student. So each student will have a cumulative credits taken and cumulative credits earned and cumulative GPA like this. So basically, because this cumulative total depends on each student, we can simply save that information here in the student entity. So for each student, we will have information about cumulative credits taken, cumulative credits earned, and cumulative GPA and cumulative total grade points like this. So that's it. So basically, here, this will be the final sample answer for the question 2 in this case.